using the Sheffield School of Architecture Artificial Sky worksheet. So this short video is intended to be used in addition to the other videos on the Media Unit website. The other videos explain how you use the artificial sky and the Heliodon, and this video is showing you just how to use the Sheffield School of Architecture Artificial Sky worksheet that I have developed recently as hopefully a more graphic and easy to use means of recording your results when using the artificial sky. First of all, let's show you where to find it. If you go to the School of Architecture homepage and click through to About SSoA and then go through to the Facilities page, and if you look over on the right, you've got the link to the Media Unit website. Click on that. Of course, you can get straight to this website. The address is ssoa-media.blogspot.co.uk, as you can see up here. Okay, and you want to go under daylight simulation. And you see on that page we've got, just scroll down a bit, we've got the two guides there to the artificial sky and the Heliodon, and shortly this video will also appear there. And at the top of the page you've got the artificial sky worksheet. So first of all is download a copy. So click on download here. That will take you into a Google Drive page. You just click on list view, make things a little bit clearer. Two documents there. You've got a blank worksheet. This is version 1.2. And you've got an example worksheet which has been completed. I will occasionally update the worksheet, so the version will change occasionally. So first of all, let's look at the example worksheet just to show you a completed example. Now that will open in a Google viewing window, which is not terribly useful. What you need to do is just click on this little pop-out button here, and that will open it as a Google Sheet. So if you look along the bottom, the important thing is that there are a number of tabs for this sheet, and the different tabs give you different interpretations of the data. And the first page records some of the basic information about your project, and the other tabs then record the inputs. I will explain this in more detail in a moment using a worked example. And then different interpretations of your data inputs. Okay, so that's what a completed worksheet looks like. You're probably familiar, if you're using Google Chrome, you can zoom out. So if you find that the worksheet is not the right size in your browser, just zoom out a bit or zoom in a bit. You can do the same in other browsers, of course. Okay, so that's the completed worksheet. Let's just close that down. Let's go back and let's open a blank worksheet, and let's quickly work through an example. So again, click on list view so you can see which is which, and this time we'll just click on a blank worksheet. That will download, and again we'll go to our little pop-out here. So that's now opened in a Google Sheet view, and I'll just actually zoom back in a bit there because I've made that a bit too small to see. Okay, and first thing we'll do is we'll make a copy and we'll give it a name. So let's call it let's call it gallery room 1 study A. So give it a sort of logical name that means something to you. Okay, and then usual, as with other Google documents, you go under File here, and you can move it to where you want. Move it to one of your Google folders. Okay. Right, so first page, let's just have a little look through this. Version 1.2, that's just the version of the worksheet. Project, let's call this Sheffield Gallery. Room number, let's call this, we were calling this Gallery 1, weren't we? Gallery 1? Yeah, Gallery room 1. Room type, exhibition. This is just for your own benefit. Simulation number, because you might be running multiple simulations, so multiple testing. So we'll call this A for the sake of it. So that's just for our own benefit. Let's just put some notes in. First test of the gallery with skylight config 1, let's call it. So just for your own benefit, just to remind yourself what you've tested here. As I explained in the other video, the important thing about the artificial sky is to then iterate your design and retest it. So this just gives you space to record what you've done here. Okay, so then let's go up into these inputs at the top here. It might look a little bit complex, but it's not really. So important thing here, external illuminance. So this is the reading you're going to take either on top of your model or outside of your model in the artificial sky once you've let the lights warm up for about 15 minutes so that they're no longer getting brighter. So that's your external illuminance. So let's just put something in there. Let's call that 5,000. And then here we've got our transmission factors. Glazing transmission factor, glazing bars, maintenance factor. As explained in the other videos, and I'll provide a few some references for typical values, but these are fairly typical values here. So just input your values in here or leave them alone if you're happy with those. And those values will then be used in the worksheet. Okay, next thing is scale unit, but we'll come back to that in a moment. That is just about defining how big your model is and how detailed you want it to look. So we'll come back to that in a moment. Let's go over to our Inputs tab. The Inputs tab, this is where you will input your readings from the artificial sky. So the first thing to do is think about how big your model is, how big the room floor plan is, how precise and how detailed do you want your readings to be, and how many readings are you willing to take. So you don't want to be taking 100 readings in your model, which would be sort of far too close together really to be necessary. So let's go. What we're going to do is we're going to make a rough floor plan here of our building, and the scale factor will set how big each square is. Now the important thing to remember with this worksheet is this will not give you a kind of graphic output like you would get from computer software. So you know, it's a bit sort of crude. Everything has to be done on a grid, in squares. We're not going to be drawing kind of complex shapes. We will just approximate it, which is perfectly adequate for physical daylight simulation. So let's just go back to our first page, sorry. I'm going to set the scale unit at 1 meter. So not the 0.5 that I had. I'm going to set that at 1. And if we go back to our inputs, you can see now that the scale factor of our squares have changed to 1 meter. And let's say that our building is, let's say that it's 6 meters by 10 meters. All right, so if I just highlight that, that would be our sort of size of our room in the building, which would then be represented with our scale model. And so each one of these squares, we would need to input a figure. So you need to look at that and decide, is that far too many readings, or is that about right? You know, I'm happy to take that many readings in the heliodon. In the artificial sky. Now the thing about the worksheet is it does make it quite quick to input the readings, so you may take more than you would have done without the worksheet. So let's assume that. Let's stick with this. This looks like it kind of works. Okay. Now you saw in the worked example what I'd also done was just drawn a few sort of rough lines to indicate where the windows are. But you know, really, it's up to you. That would be purely for sort of graphical purposes. But you know, like as you can see there, I've kind of indicated a window. But yeah, you know, that's completely up to you. Okay. Now, what you can also do is, what you might want to do is just to shade the squares around your building. Just shade them a grey so that you're not accidentally recording them. Or what I actually find is just as easy, to be honest, is just to draw a box around your room like that. And to be honest, I'm not really too worried about whether I can see where the windows are. So that's our room. So imagine now that we're in the artificial sky, and let's start taking some luminance recordings. Okay, so imagine we've got the light meter in. We're going around the building, going around our floor plan, taking readings and typing them in directly into the worksheet. You can do it on an iPad, on a tablet if you want, like this. And what would be helpful is if our model in the artificial sky had a grid marked on the floor corresponding to this grid, and that would just help us to put the light meter in the right place. Okay, so let's say we go, let's just take some more readings here, typing them in Lux, of course. Okay, so that's the kind of process. Now normally, oops, change that one. Normally without the worksheet, that's an illuminance reading. You would then have to, if I go back to the first page, you would then have to plug all of those readings into the daylight factor equation to get a daylight factor out of it, which is a little bit time consuming. What the worksheet does is it just does it for you. So if we go to the next tab, which is DF, daylight factor colored, if we go into there, then what you can see this sheet is doing is it's converting our illuminance into a daylight factor. And it's doing it automatically. And then what it's doing is it's applying this color code to that daylight factor. So what I should just do in here, probably for clarity, is just draw the border around our room again. So we've got daylight factors, 21, 17. I just go back to the inputs, and I'll just put in a few lower values so you can see how it looks when you have lower daylight factors. Obviously, I'm just making these up for the purposes of the demonstration. So I've added a few lower illuminance values there. Go back to our coloured sheet, and you see you get a coloured scale. So you get the daylight factor figure calculated for you, and you also get a colour code. All right, and the key is over here. If we just scroll down a bit there, this worksheet also works out for you the average daylight factor in the room, the minimum daylight factor in the room, and the uniformity ratio of the room. Okay, now I'm not going to explain, the purpose of this video is not to explain what those all mean, but just to show you how it works. But it does automatically calculate those for you. If we then look at the other sheets along the bottom, we have a grayscale view, and again, draw your floor. I'm afraid it doesn't automate. Not sure how to make that work. It doesn't automate this little rectangle that you draw around your room. You have to do that yourself at the moment, anyway. But what it does do is it automates again. Daylight factors appear here, and this time we have a grayscale to those daylight factors. Okay. And if we go to the final sheet, it's the same data, but what we've got here is a different. You can customize the key basically here. So what I've got at the moment is anything in the range from 0 up to 2%, or 1.9% to be accurate, will appear in this dark red. And so that's a very sort of clear indication where parts of your room are dropping below 2%. And then also anything above 10% is coloured in yellow. And again, that would give you a good sort of indication of where perhaps you've got too much daylight. Okay, and again, same on every sheet. You have these other calculations done for you. Okay, I'm just going to complete the rest of the sheet. So I'll skip to that, come back when it's completed. Okay, so you can see now that I've completed the inputs for this room. As I said, I was making them up, so I'm not sure how realistic they would be, but I've completed all those illuminance inputs. And if we now look at our coloured sheet, we have a coloured display showing the daylight factor. So we're sort of very bright here near the window, dropping away into the corners of the room. Probably not a very not a very realistic plot, to be honest. Okay, then we have the same in a grayscale, showing that fall off away from the windows. And then in our key values, we have this display which shows a bit of a simpler color scheme where everything above 10% is yellow, everything below 2% is this sort of dark red, and everything in that 2 to 10% is blue. Okay, so that explains the worksheet. I encourage you to have a go with it. If you're using the artificial sky, I think you'll find it a lot easier than just writing down your values on a piece of paper. Once you've got the results, once you've got these outputs, you can always, of course, export these images as JPEGs or PDFs and overlay them over your drawings or use them however you wish.